Welcome to the second video of Unit 4. We're going to do 4.1 linear relationships. All right, the learning intention today is to be able to graph and analyze or interpret a proportional graph. And our success criteria, right, you understand it when you can identify a proportional relationship, you can graph a proportional relationship, and then you can find and interpret the slope of that relationship for me. All right, let's see what that looks like. All right, so here are some important definitions you probably should jot down, kind of need to know. So unit rate is the ratio of input and output, right, x to y, of any point. Now, your rate of change and your unit rate and your slope should all be the same if you have a linear relationship, right? So that's step one of identifying whether you have a linear relationship or not, right? If your unit rate is the same as your slope, in other words, your unit rate is constant for every point, then you have a linear relationship. And to follow that up, you know you have a proportional relationship when your relationship is linear and passes through the origin 0, 0, right? Or like the bullseye, like the crosshairs of your graph, right? Where the coordinate planes meet x and y axis. That's where your origin is, 0, 0. If it is a straight line and it passes through 0, 0, you got yourself a proportional relationship. All right, so the only thing left here is to get into an example. And here we have our only example for the section because I think our practice is going to be enough. So, the number of times y a honeybee can beat its wings in x seconds can be represented by y equals 200x. Determine if the number of times a honeybee can beat its wings is proportional to time by graphing the relationship on a coordinate plane. So all you're going to do is you're going to fill out a chart and then you are going to graph your coordinate planes. Let's get a look at that. Using the linear equation from the problem, I've created the XY chart, the XYT graph, T-chart, whatever you want to call it. And we found coordinates by plugging in input values for X. So we have our linear equation highlighted here, Y equals 200X, and I plugged in the values 0. 200 times 0 is 0. So our output Y was also 0. So right there, you know this is probably going to be a proportional relationship because it's starting at the origin. But you have one more thing to determine. Is it linear? Does it form a straight line? So we need to find some more points. So we're going to input 1 for our x value. 200 times 1 is, guess what? 200. So our output for y is 200. Input of 2, 200 times 2 is 400. Input 3, 300 times 2 is 600. And if you take a look, our x is constantly increasing by 1. Our y's are constantly increasing by 200. This is probably going to be proportional and linear, but to make sure you must graph. You have to have a graph. So let's put our points on the graph. Here you can see 0, 0, 1, 200. Remember, if you read the y-axis, this is the number of beats in hundreds. It's not just 2. Go to 2 seconds, boom, 400. Go to 3 seconds, boom, 600. Make it, connect your dots. That's a straight line, goes through the origin. This is proportional, and we are done. If we ask you to find the slope, you would just go back to your equation, and you would simply look what is being multiplied by x. That's always your slope in a linear equation. So 200 is what's being multiplied by x. Guess what? Your slope is 200 over 1, or just simply 200. All right, so we're going to go over some practice in class, and I think you guys will get this. Have a good day.